I'm going to switch back now down to the local level, back to the farmer level, and share with you some work that we've been doing with farmers in the San Joaquin Valley of California, and related to several of the conversations or presentations you've heard over the last couple of days around on-farm recharge and the grower acceptance of this as a practice. We're looking in the east side of the southern San Joaquin Valley primarily because this area overlies some of the most critically overdrafted groundwater basins in the state, and because also, as you heard from Joel Kimmelschuh, if you were in his session, these are some of the most appropriate lands for recharge given both the soils and the subsurface geologic conditions. So we see this as a high probability. And I should just mention I'm with a nonprofit organization, Sustainable Conservation, and we work with a diversity of landowners, businesses, and government agencies to find solutions to environmental problems that make economic sense. We also start always working from the bottom up, working with landowners with great ideas. And we started this effort working with Don Cameron at the Terra Nova Ranch, along with actually Phil Bachand, maybe here, helped identify this site as one of the few locations in the state where a farmer was actively taking floodwaters when they were available, putting them on his active farmland for recharge purposes. And Don did this, as several of the other presentations have mentioned, both during the winter season on his grapes, but all the way into the midsummer or to early summer, when the grapes were active, and which a lot of folks questioned as being a viable agronomic practice. And he had no yield declines on his grapes whatsoever. He also practiced this on almonds, pistachios, and alfalfa in a more conservative manner earlier in the season. And at some of the early workshops that we participated in to help tell this story, the neighboring growers that came to those meetings frankly told Don that he was crazy, and that they wouldn't have anything to do with this, and they thought he was going to lose his farm and his production doing such a thing. And yet this offered a viable alternative for thinking about groundwater management before SGMA had even been passed. And what may be crazy is not doing something about enhancing our supply side of our groundwater management. And right now, some groundwater management agencies do focus on doing recharge using dedicated recharge basins where the land is purchased and constructed basins are installed and floodwaters are captured on those lands. And those have certainly provided significant recharge for decades throughout the San Joaquin Valley. But we're also thinking about what other methods could be used to enhance the rate at which we're capturing floodwater or available water to enhance groundwater supply before we start talking about demand restrictions. So farmland poses a viable, or at least an option that we think should be considered, along with the idea of fallow land, because if demand is restricted and pumping's cut back in any way, there may be more fallow land showing up as there has been during the recent drought, which would also provide a very good location to park water essentially during peak flows and get it to recharge to groundwater. So how do you decide between these methods? We conducted an economic evaluation comparing the capital costs and operating costs amortized over 20 years per acre foot of water that you can store in these two different methods. And the on-farm approach varies from about $40 where the irrigation canal and conveyance, flood irrigation conveyance is already in place on a farm, to farms where they may have to build larger constructed canal systems within the farm to move water throughout. And then on a dedicated basin that was recently built in Laguna Irrigation District to about $124 per acre foot, which we understand is actually fairly low compared to the cost of some basins, depending on the price of land. So looking at those cost comparisons, one of the questions for irrigation districts that we've been talking with is how do they make this decision between investing in more land for purchase for dedicated basins versus promoting on-farm recharge. And in the upper half here, looking at the Kings River winter flows, November to March, the Kings River irrigation districts have done a really good job of capturing the average flows in that basin, highlighted in orange in this chart. Those are current winter diversions. But it's those peak years in our infrequent rainfall seasons that really is where the economic question comes up. Does it make sense to buy more land for storm events that only occur every 5 to 10 years, to buy land at agricultural rates and dedicate it to this, or use farmland? So in each basin, irrigation districts are trying to assess this. In the Merced River, you can see that the winter flows are not really captured at nearly the same rate as they are in the Kings Basin, and there it might make sense to purchase more land for dedicated recharge basins to take the average flows off, but then think about farmland or fallow land for capturing those other peak storm events. All of the idea about putting water on farmland hinges, of course, on farmer acceptance. And so we went back to Don's area where he had been practicing this on about 1,000 acres. And we talked to all of the neighbors, or 80% of the neighbors in that area of a 16,000 acre region, to survey those farmers to find out what they thought of this idea, besides him being crazy. And we interviewed farmers that grew grapes, almonds, pistachios, corn silage, alfalfa, to ask them a variety of questions around it. And what we ended up learning from these farmers is that for them, the critical factor, the most critical factor, is that they have control over the amount and timing of the water that they take. They don't want to be part of some program that tells them, you will take water on March 1st because that's when the water is here. They need that flexibility for their crops and to manage their productivity. And even though the river may be full, they don't want to be told to take it at that moment, which creates uncertainty then for an irrigation district or a GSA trying to manage those peak flows, is where are you going to put that water? We asked them a variety of questions around how they would like to sort of sign up for this. And again, there's only 12 growers in this 16,000 acre area, but they did say that specifying the maximum amount of water they would take was the most acceptable approach. The least acceptable was establishing dedicated land for permanent recharge basins on their land, because just like the irrigation districts, they knew, I don't want to give up that land for those 7 or 8 years between storm events. They want to maintain that productive access to the land. Also, in terms of crop type and seasonality related to when they take water, we're actually quite surprised to find that in green is really the winter months, November through March, and then the blues and yellows gets out into more the crop production time of year. And we were surprised to see that a lot of the crops from these growers, they were willing to put excess water beyond the crop's demand into the early summer months. Again, them controlling how much extra that was. But a drop-off, you notice, on grapes and raisins, and some of the other crops have some drop-off as you move further into the season. So we also found that larger diversified farms tend to have more flexibility. They can choose where to put that water, if it's available in February versus in April, whereas a small farmer that has an 80 acre block of almonds was most likely to say, I'll only take it during the winter months and not beyond. The fact that floodwater delivery costs vary quite a bit is an economic factor. If they have to pay for the water, that's a critical factor in deciding whether they would take it. Certainly in locations where an irrigation district would subsidize or encourage the use of the water through reduced prices, there's much greater interest. The big one that you've heard several probably talks here this week about is the uncertainty of the risk to the crop. What sort of crop pathogens might be created through this type of flooding, and what would be future yield problems a year or two down the road. And Helen Dahlke and others are doing research on this piece. Also on some farms, these lands have been converted entirely to micro sprinkler irrigation systems out of sort of the drive to conserve water and be more efficient. Those locations then don't have the capacity anymore to be able to put those lands that are under sprinkler or under drip irrigation back into flood situation and capture that rainfall. And that's where additional costs would be faced. And of the growers in the 16,000 acre area, the ones that are in blue-green on the left-hand side of these charts have either flood or flood and drip. In other words, they have a dual system and they can capture flood water. Those that have converted entirely to drip and micro-sprinkler, of course, have less or much more restricted in their ability to participate. And then finally, groundwater quality. We were interested to hear in terms of nitrate leaching issues. And when we asked the question, are you have concerns about water quality, the first answer was, our biggest concern about water quality is the quality of water we're pumping out right now with depleted groundwater. That we're seeing declines in our water quality with salt buildups and minerals. And that, in fact, putting water on was less of a concern. Certainly not a concern about losing nitrogen, but some concern about regulatory actions that could be taken under water quality protection laws. 67% said they have water quality concerns, but that was that mix of those two types. So we've been presenting to those farmers what information is known so far from both some of the early study work as well as the engineering and economic costs. And we've now had 3 years of drought, and now we have sigma. And at our last meeting with the growers in Don's neighborhood back in spring of, actually it was in 2015, the growers came up after the meeting, and every one of them went up and shook his hand and thanked him for being the one to test this idea out. And they have all increased in terms of their interest in this. And we started to hear interest beyond that neighborhood as to what would be the adoption of this practice statewide. And so we conducted really an outreach effort, tapping into corporate partners, crop associations such as the Almond Board, irrigation districts, to reach out to as many farmers as we could to find out who else was interested in this idea and might serve as demonstration sites and research sites for folks from the universities and others to be able to assess the feasibility of this over the San Joaquin Valley. As a result of those outreach efforts last fall, we were able to identify 131 farm sites up and down the San Joaquin Valley, representing 10 different crops and over 14,000 acres, where farmers were interested in participating in some way in figuring out whether this is a fit for them and for the state. And as I said, really we're at the demonstration and assessment state. This is not at a point of being able to make recommendations. This is participatory research where these farmers would be part of it. So the rest of the time I want to share with you a little bit about what we've learned from those 23 landowners on those 130 sites. Their crops represent a variety, primarily permanent crops, pistachios, almonds, and grapes, some fallow land, and a variety of lesser tree crops. In talking with them, 27 of the sites, of those 131 sites, had already been used for accelerated application of water for recharge. And the definition here with the growers was, are you putting on water in excess of the crop demand with the purpose of achieving some recharge? Many farmers apply excess of crop demand for salt leaching, but this was with the intent to actually move water down further. And of those that have actually been practicing this in the past, we had a good cross-section of almond, grapes, some row crops before planting, as well as pistachio and walnut. So in talking with those farmers, what we've learned from them is that they typically put on irrigation water in 6-inch amounts at a time, let it dry down, put 6 inches more on, let it dry down. They all are on very sandy soils where it moves through the soil profile very quickly. No heavy soils represented in the sample. And in terms of fertilizer management, which we were concerned about, the typical management has been to post-harvest apply in October, and then typically they've applied in February or March. All of these growers said they would delay their fertilizer application by 1 or 2 months if they knew that there was going to be sufficient water to recharge in any given year. So in going back to the larger sector of all the 130 sites with the 23 farmers, we did ask them all about how late into the season they'd be willing to apply this excess water for recharge purposes. And we had quite a spread for each crop in terms of which month they would consider the last month at which they would do this. And this goes beyond the conventional advice of farm advisors and agronomists in terms of these permanent crops, recommending application only during the dormant season up through March. And when you break this set down and look at who are the farmers that are already practicing this, it turns out the farmers that have been practicing this in the past are the ones that have pushed the limits further out than the agronomic advice that exists right now. So those farmers have been testing it, taking the risk, and those are the farms that we really want to be able to evaluate further in terms of, has there been any crop decline? According to Don Cameron, no, and according to most of them, no, but it'd be good to get more data on this to see how much further out we can push these numbers and learn more about the specifics of how they're applying it and the duration of saturation in the root zone. In terms of fertilizer application, again, from average, talking to all the farmers, quite a range in terms of the earliest time that they put on fertilizer on these different crops. But when asked if water was available, could you delay that, the date shifted about a month forward where they could accept water or put on fertilizer. And then we also looked at, in terms of the soil types, using UC Davis's sustainable or soil agricultural groundwater ranking system. And on a scale of 1 to 5, all the sites that were offered tend to be on the better side for suitability for recharge. Interestingly, the ones that have been practicing recharge have pushed that limit down a little lower to 3.4, which starts to move you into the good to average. Oops, got a battery shortage here, technical folks. So I think the bottom line here is that we don't exactly know how far this can be pushed, but the growers that are doing it are pushing the limit beyond what we had expected. So now there's research going on 2 of these sites where water was available this winter with UC Davis, Berkeley Labs, Phil Bichond, and others to answer some of these key questions that remain around challenges about nitrate leaching and crop suitability, as well as for the districts and water managers, clarity about water rights in these later seasons, and also what incentives farmers that participate in this would require or need to handle their risk. And then in terms of irrigation districts, how they're going to move beyond sort of centralized permanent recharge basins to managing a dispersed type of approach like this if farmers are in fact willing to, and the economics show that being the most economic way to capture those peak flows. So I will stop it there at that point.
You had said something earlier on that the main question or only question is farmer acceptance. I think since you're talking about flood flows that in our systems do a lot of geomorphic work in these natural systems, it's really important to consider that it's not just icing on the cake that you might be taking off, and that if we start removing the flood flows and reduce that work, we're actually going to increase endangerment of some of the species that are regulated, which could actually therefore have an impact on surface water allocations in the future. So we're thinking about what are you actually taking off the top, and where's the top? And if it was reclaimed water, I don't think it would be as much of an issue, but I wouldn't assume that those peaks aren't doing something useful.
Yeah, 2 comments on that. Certainly in terms of base flows, the water availability is above and beyond the base flow portion, but the morphological effect of those peak flows. The way I like to think about that is these are leveed river systems, and if those levees weren't there, the water would be out on the floodplain during those peak events. And so really what we're doing is reconnecting the river to its floodplain in a very managed way rather than blowing out levees. So the question now is, how do we want to manage those leveed channels, essentially? And do those peak flows actually assist in morphological function in those leveed channel systems? Or as you said, downstream, there's those benefits as well. I think those are questions around both water rights and DWR's analysis of what water is actually available for recharge.
Thank Daniel again. That concludes this session. We'll be starting up